In the first example problem on the board with adding and multiplying vectors, we are given two vectors A and B. And A has horizontal and vertical components 4 and 8. B has horizontal and vertical components 3 and -5. And we are asked to find what is A plus B first of all. Before I do that, I'm just going to show how I could draw these vectors on an XY coordinate system. So I could say here is the y-axis, here is the x-axis. Now, when I see this, I will imagine both vectors beginning at the origin. In this course, you are allowed to pick up vectors, move them around on the page, but drawing it from the origin is, in what we're doing right here, the easiest thing to do. So, AX is equal to 4, so 1, 2, 3, 4. AY is equal to 8. I will move 8 in the vertical. 5, 6, 7, 8. So vector A is going to look something like this, where AY is equal to 8 and AX is equal to 4. Now vector B, if I were to draw it on the same diagram, 3 in the horizontal, -5 in the vertical. Saying -5 in the vertical is the same thing as saying 5 downward. So I could say 1, 2, 3 to the right, and 1, 2, 3, 4, 5 downward. So vector B is looking something like this, where we have Bx is equal to 3, and By is equal to -5. And now we are going to add these two vectors together. So we said the way we add vectors is we add their components individually. As then somewhat of an aside, right now we have A plus B written on the board, but I like to create a new vector and give it a new symbol. So I'm going to invent vector C, and I'm going to say C is A plus B. The reason I'm saying that, say I write this on the board, if you see this, what comes to mind? The first thing that might come to mind is this is a math equation to be solved. So 16 plus 4 is 20, minus 10 is 10, plus 2 is 12. But it is true, this is an equation, but everything over here, this is a number. You should be able to look at this and agree that this thing inside the box I drew right here is a number. It just is stretched out in a certain way. Very similarly, this thing right here is a vector. But when I see it, because of the way it's written, I see a plus sign, I see some other vectors, the first place my mind goes is an equation to be solved. But when I see this, I should think of this as a single vector with a horizontal and a vertical component. By writing C equals A plus B, now I'm trying to find Cx and Cy. And this is basically the same thing as find the vector sum of A plus B. It's written in a bit of a different way, but it helps my mind think about what I'm really trying to do here. So I'm going to write C equals A plus B. And we said when we add vectors together as A plus B, we add their components individually. So by adding the components, that means the horizontal component, or the x component of C, is the x component of A plus the x component of B. Now, I gave you both the x component of A and B over there, so we have enough information to just plug numbers in and get an answer. So AX is 4, BX is 3, so I get CX is equal to 7. Very similarly, I could say CY is equal to AY plus BY. So CY is equal to 8 plus, and this BY is whatever is on the right side of the equal sign. The negative sign is on the right side of the equal sign, so I do need to remember to include it. So I'll put parentheses negative 5, and this becomes 8 plus negative 5, that is equal to 3. So Cx is 7 and Cy is 3. So if I were to draw vector C, it would look something like this. So here are my x and my y axes, and I could say Cx is 7, 1, 2, 3, 4, 5, 6, 7. Cy is 3, 1, 2, 3. So vector C has component Cy is equal to 3, and Cx is equal to 7. In the next problem, we are subtracting vectors, and I'm going to give you two different ways we could think about that. So the first way, we are told that we are doing a minus b, and again, I'm going to create a new vector. D looks kind of similar to b, so I'm going to call it vector f for fun. Now, vector f is the vector subtraction of a minus b. And so one way I could think about this is I could say we will subtract the components of b from the components of a, just like as though we were adding them. So I could say fx is equal to ax minus bx. So ax is 4, bx is 3, so I get fx is equal to 1. And similarly, I could say fy is ay minus by, so fy is going to be 8 minus, again, by is everything on the right side of that equal sign, which includes the negative, so minus negative 5, and fy then is going to be 13, minus negative 5, same as plus 5. So if I were to plot vector f, I would have, here is my x-axis, my y-axis. Vector f is going to be 1 to the positive x-axis and 13 in the direction of the positive y-axis. So vector f will be something like this, where fx is 1 and fy is 13. At this point, we're done with this problem. If I wanted to, I could solve this, or not even solve this, I could think about this problem in a different way. So this other way of thinking about the problem is a bit longer than what we did. If I am solving a subtraction of vectors, I will use this method I just shown you because it is quick. But this method I'm showing you is more akin to the idea that I had in the lecture slides of a minus b is really a plus negative b. So what is this negative b that we're talking about? Well, negative b is the same thing as negative 1 times b. So I could write negative b is equal to negative 1 times vector b. And we learned from the slides of multiplying vectors together that when you multiply a scalar by a vector, here's a scalar, here's a vector, you multiply that scalar by the components of that vector individually. So I would say negative b has components negative bx, which is negative 3, and negative by, and negative 5, which is just 5. So the horizontal component of negative b is negative 3. The vertical component of negative b is positive 5. So when I subtract a minus b, it's like saying fx is equal to ax plus negative bx, and fy is equal to ay plus negative by. So at this point, I would say this is equal to 4 plus negative 3, which is 1, and this is 8 plus negative -5, which is equal to 13. So again, we still have the exact same components of vector f. We just worked out a little more in the spirit of a minus b is really a plus negative b. For the last example problem of this exercise, we are asked about this vector 3a minus 2b. And I'll call this vector g. So I have my vector g as 3a minus 2b, and I'm going to look at these terms individually. So for the term 3a, well, if ax is equal to 4, that implies 3ax will be triple that. So triple that would be 12. And if ay is equal to 8, triple that number, multiplied by 3, is going to be 3ay is equal to 3 times 8. That's going to be 24. Similarly, for 2b, I could think of it as bx is equal to 3. That implies 2bx is equal to 2 times 3. That's equal to 6. If by is equal to -5, double that value. 2 times by is going to be 2 times -5. That's going to be -10. So at this point, I could take these numbers and insert them in here. So I could think of gx as being 3ax minus 2bx. So 3ax, we said, is 12 minus 2bx minus 6. So that's going to be 6. Similarly, I could say gy could be thought of as 3ay minus 2by. So I could write that as 3 times ay is 24 minus 2 times by we said is -10 minus -10. So that is 34. So if I were to draw this vector, I would say gx is equal to 6, gy is equal to 34. And now I have enough information to go ahead and draw this. I know what the components of vector g are. So here is my y-axis and my x-axis. Gx is equal to 6, 1, 2, 3, 4, 5, 6. Gy is 34, 1, 2, 34. So vector g is going to look something like this, where the vertical part of vector g, gy is equal to 34, and the horizontal part of g, gx is equal to 6. Now, this is a bit of a longer way to do the problem. There's a shorter way we could do the problem that will be correct. The shorter way to do this problem is to look at this and think of this as gx is equal to 3ax minus 2bx. And at this stage, we could just plug the numbers in directly. So we could say gx is equal to 3 times 4 minus 2 times 3. So 3 times 4 is 12, 2 times 3 is 6. So we get 12 minus 6, gx is 6. And similarly, gy could be thought of as 3ay minus 2by. So that would be 3 times 8 minus 2 times -5. And again, 24 minus -10, 24 plus 10, that would be 34. So at the end of the day, the components of g we found are going to be identical. Although notice that for everything we did throughout this video, we never mixed x components and y components together. Whenever you add vectors or subtract vectors, you will never ever want to mix the components together. The x's are all together in whatever pattern they happen to be found in. The y's are all together in whatever pattern they happen to be found in. And you don't ever want to see any x components mixed in with some y components when you're adding vectors.